Let's do 3.2. A geometric sequence. In an arithmetic sequence, you have the same first term. So we have our A, which is the same for the geometric sequence and the arithmetic sequence. The common ratio of the geometric sequence is 1/3. So R is equal to 1/3, right? And then the common difference of the arithmetic sequence is 3. So D is equal to 3. Right? The sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity for the geometric sequence. So how can you represent this? So we're saying the sum of the 22 terms of the arithmetic sequence is what? 734 more than. So it means we have to say this is equal to sum to infinity plus 734, isn't it? All right. So now we can find our sum of the 22 terms of the arithmetic sequence and then find our sum to infinity and then add 734, right? And then we solve for A. Okay. Let's find the sum of 22 terms. So Sn is equal to n/2, then 2a plus n minus 1d, right? And then we have our difference. We have a is just the same. Then n is 22. So S22 is equal to 22/2, then 2 times a, then n is 22. So 22 minus 1, that is 21. So it's going to be plus 21 times 3, right? We can simplify this. This becomes S22 equal to 11, then 2a plus 63. Okay, right, let's distribute 11 here. So sum of 22 terms is equal to 22a plus 693. Let's just name it first equation. But let's have the equation for sum to infinity. Sum to infinity is equal to a over 1 minus r. Or r is 1/3. So our sum to infinity is equal to a over 1 minus 1/3. Right? 1 minus 1/3 is like 2/3, isn't it? So it means our sum to infinity is equal to a over 2/3. So we're dividing by 2/3. Remember, when we say a divided by 2/3, just same as a times 3/2, 10 times. It means our sum to infinity is equal to 3/2a. Right. Let's come back to this. We said the sum of the first 22 terms for arithmetic series, this is equal to sum to infinity plus 734. Let's just substitute here, or sum of the first 22 terms and sum to infinity. So what we have, 22a plus 693 is equal to our sum to infinity, which is 3/2a plus 734. Now we can solve for a here. So what do? We can multiply everything by 2 to get rid of the denominator. So it's 44a plus 1386 is equal to 3a plus 1468, right? 44a minus 3a, that is 41a, is equal to 1468 minus 1386, that is 82, right? Then divide by 41 on both sides of the equation. A is equal to 2.